Okay, our very last video, we should be able to finish pages 16 through 20. So we want to perform the indicated operation, and we want to simplify. All right, so anytime you're given something like this and you see rational expressions, algebraic fractions, and they're dividing or multiplying, they're asking you to simplify it, which means you have to factor. Is one of the first things we're going to try to do, and then we're going to cancel. Okay? And remember, we cannot cross anything out that's attached to something else with a plus sign or a minus sign. So I cannot cancel this x and this x because this x is attached to that 6 and this x is attached to that 12. So remember that. We can only cancel out binomials. So I'm going to take a look at this first fraction and I'm going to factor it. So there's the fraction bar. I'm going to look at the top, and the first thing I'm going to try to factor out is a GCF. And the greatest common factor is 3. There is one. So I'm going to write that down. And then I have to figure out what's left. Well, what do I multiply 3 by to get 3x? That's going to be x. Plus, what do I multiply 3 by to get 6? And that's going to be 2. All right, so we're going to write 3x plus 6 as 3 times x plus 2. I'm now going to look at the denominator, which is 4x plus 12, and go through the same process. Is there a GCF? The answer is yes. What is it? It's 4. What do I multiply the 4 by to get the 4x? X, then plus, which is the same sign as I see here. And then what do I multiply the 4 by to get the 12 back? That's going to be 3. All right? Then remember, when we're dividing fractions, it's stay, change, and we're going to flip, which means we're going to take the reciprocal of this. So there's my new fraction bar. The denominator is x plus 3. I'm going to put that in the top. Remember, that's a binomial, so I'm going to put parentheses around it. That's a reminder that I can only cancel the entire thing out with something else. I can't cancel a piece out. And then I have x squared minus 4, and that's going to go to the bottom. But let's take a good closer look at it. Can I do anything with it? Well, there is no GCF. But is it the difference of two perfect squares? The answer is yes. And by definition, we know we break that up into two binomials. The positive term is x squared, so its square root comes first. So the square root of x squared is going to be x. My signs and the difference of two perfect squares is always different. And then what's the square root of 4? And that's going to be 2. All right, so everything now is canceled. Everything now is factored. Now we can begin to cancel. Anything that's the same in the top and in the bottom, so entire binomials can cancel, just like that. X plus 3, x plus 3. All right, there is nothing else in the top that can cancel, so I'm just left with just 3. And then the bottom, I'm left with 4 times x minus 2. All right, since the directions say to simplify, we're supposed to leave this fraction so we can't do anything else to that. So the 3 stays in the top, and I'm going to distribute the 4x through. That's 4x minus 8. And there's your final answer. All right, next question is just like that one, except it's a little bit more complicated. Okay, so we're going to take a look, and it says express in simplest form, and you see the division of rational expressions. So let's make sure we look to factor first. Do not cancel this x squared and that x squared. This x squared is attached to other terms with a plus or a minus, so I can't cancel it. Can't cancel it with this x squared because of that minus sign. Okay, so we're going to have to look to factor. All right, well, the first thing I'm going to do is I'm going to try to factor the easier pieces first. All right, well, 6x squared is in the bottom and it can't be factored at all, so I'm just going to rewrite it. And then division is going to change to multiplication, and then remember, we're going to flip this. Flip it. So now what happens is the x squared plus, or x squared minus 3x is going to come up top. And now take a good look at this. All right, let's see if we can break that down any further. We're going to start with the GCF. Is there a common factor between x squared and 3x? And the answer to that question is yes. What is it? It's x. That's the greatest term that will go into both pieces. Well, what do I multiply x by to get x squared back? That's x. There's my minus. What do I multiply x by to get 3x? The answer is 3. So now that piece is factored completely. The next piece, which is x squared minus 9, that's in the numerator, but because we flip the fraction, it's going to go down to the denominator, and we look at it very carefully. Is there a common factor? The answer is no. Is it the difference of two perfect squares? The answer is yes. So by definition, we're going to break that down into two binomials, the sign of which are always different, and then the positive term is x squared. Its square root comes first, x and x, and the 9 is negative. Its square root comes second. Okay? The last piece is this 2 times x squared minus 8x minus 42. All right, if you have this leading coefficient of a 2 in front, look hard for the GCF because it makes our factoring a little bit easier. And sure enough, there is a common factor of 2, so I'm going to pull that out. What's left is going to be 2 times what is 2x squared, that's x squared. 2 times what's a negative 8x, that's minus 4x. And then 2 times what is a negative 42, that's going to be a negative 21. All right, I'm going to bring the 2 down because that's going to be part of the answer. That I'm then going to have to try to cancel things out. But now I have x squared minus 4x minus 21. There is no longer a GCF. It's not the difference of two perfect squares because there's 3 here. So this is your quadratic. And quadratics are going to factor in the two binomials. Since it's x squared, we know it's x and x. To determine the signs, since that's a minus, the signs are different. So we put them in, plus and minus. And then factors of 21. Well, 1 and 21, 7 and 3. Which pair of factors have a difference of 4? And that's going to be 7 and 3. And then I need a negative 4, so I need to put the 7 by the negative and a 3 by the positive. All right, and now we can start to have some fun and cancel and see what we wind up with. We have an x plus 3 in the top, and we have an x plus 3 in the bottom. We have an x minus 3 in the top, we have an x minus 3 in the bottom. Now, because this is 6x squared, I don't see any signs, any pluses or minuses linking them. They're multiplying, so I can cancel these parts. So 2 goes into itself once, and 2 goes into 6 3 times. And then same thing, I can't cancel this x with this x squared because this x is attached to the 7 with that minus sign. I'm not allowed to cancel a part of that. I have to only cancel the entire piece. But this x is not linked to anything with a minus or a plus sign. It's multiplying. So I'm going to cancel this x with one of these. That gets rid of that 2. So now if I take a good look in the top, the only thing I have left with in the top is my x minus 7. And the only thing I have left in the bottom is a 3, an x, and that's it. Please remember, do not cancel these two terms out because this x is attached to the 7 through a minus sign. That's your final answer. All right. Probability question. This is kind of a review. I'm going back. They give you restaurant sells kids meals consisting of one main. So we want one main course, we want one side dish, we want one drink. So we have a choice of 3 main courses, 2 side dishes, and 3 drinks. It says draw a tree diagram or list the sample space. Well, we're going to do both, just as a reminder of how to do this question. Okay? If we're going to do a tree diagram, remember your tree starts at a point, all right, and then we make our first choice. Our first choice is going to be our main course. Well, how many different main courses do we have? Well, we can choose a hamburger. We can choose chicken nuggets, which I'm going to just abbreviate C nuggets. And we can choose a turkey sandwich. And I'm just going to say turkey. So there's our 3 choices for our main course. Now we're going to get to our side dishes. So in our side dishes, we have how many choices? French fries or applesauce. So I have a side dish. So let's just say I chose my hamburger. That puts me here. So my main course was a hamburger. Well, after I chose that hamburger, I still have French fries, or I can go with applesauce. All right? Well, let's go to hamburger and chicken nugget. Well, let's say we didn't do hamburger first. Let's now go chicken nuggets. So our main course was chicken nuggets. That puts us here. I can still choose French fries or applesauce. Well, let's say I didn't want hamburger or chicken nuggets, but I wanted my turkey sandwich. That puts me here. I can still choose French fries or applesauce. All right, so I'm done with my main, my side. Now I'm going to go to my drink. Well, hamburger, French fries, and now I have 3 drinks that I can choose from, and that's going to be milk, juice, or soda. I can do the same thing if I choose hamburger and applesauce. Let me just make these bigger so I can get them away from here. We can go milk, juice, or soda. Chicken nuggets and French fries, same thing, milk, juice, and soda. Chicken nuggets and applesauce, milk, juice, and soda. Turkey and French fries, milk, juice, and soda. Turkey and applesauce, milk, juice, and soda. All right, so there's your tree. And to determine how many different possibilities there are overall that you can choose, you just count up the last branches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 possible choices. So it says how many different kids meals can a person order? 18 different meals. Okay? Let's say I didn't want to go with a tree diagram. I want to go with a sample space. So a sample space is just a listing of everything that can happen. So you could fix your hamburger. So that's what I'm going to choose first, hamburger. And then I can go hamburger with French fries, followed by what? Milk. Hamburger, French fries, followed by a juice. I'm running out of ink there. I can go hamburger, French fries, followed by a soda. That's everything that can happen with a hamburger and French fries. Now let me change my my side. How about hamburger, French fry, hamburger, applesauce, and milk? How about hamburger, applesauce, and juice? How about hamburger, applesauce, and soda? All right, so that's everything that can happen with a hamburger. Now let me switch. Let me go chicken nuggets. And again, now just everything else repeats, guys. All I'm doing is replacing the hamburger with chicken nuggets. So it's chicken nuggets, French fries, milk. So if you do this in a very strategic way, you can not have to rethink everything that you just did. All I'm doing is replacing the hamburger with chicken nuggets and copying each of the other ones down. Chicken nuggets, applesauce, milk, chicken nuggets, applesauce, juice, and then chicken nuggets, applesauce, and soda. And then finally, switching it up, I'm not going to take hamburger, I'm not going to take chicken nuggets. What am I taking? I'm taking my turkey sandwich. So we're going to go turkey, French fries, and milk, turkey, French fries, and juice, turkey, French fries, and soda, turkey, French fries, turkey, apple sauce, and milk, turkey, applesauce, and juice, or turkey, applesauce, and soda. And those are all of the combinations. And once again, we said there were 18. If you count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 possibilities. The other way we can do this and to find out total number of choices we have is remember what the counting principle says. The counting principle says that if we're making a choice and we're doing a bunch of things at the same time, we're picking a kid's meal. So we have 3 different choices for the main course, we have 2 different choices for the side meal, and we have 3 different choices for the drink. The counting principle says if you're doing all these at the same time, you simply multiply these 3 numbers to get your total possible outcomes. Okay? So there's a couple different ways we can look at that. So there's your tree diagram or your sample space with that answer. So that answers this first piece. Let's go down to the second piece. The second piece says Jose does not drink juice. Determine how many number of different kinds, different kids meals that do not include juice. Well, I just don't want to see a juice. So here's a juice, 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 and here's a juice. So there are 6 total kids meals that include a juice. Remember, there were 18 meals altogether, so it's just 18 minus 6, leaving us with 12 meals. Do not include juice. Okay? And last question, Jose's sister can only eat chicken nuggets for her main course. Determine how many different kids meals that will include only chicken nuggets. Well, only chicken nuggets, guys. That's this middle row. If I did a sample space, only chicken nuggets are going to be just this piece if I did the tree diagram. That's why the sample space is so nice here, because it's just right here. 1, 2, 3, 4, 5, 6. 6 different meals. And that's that. Next question. Question 38. Okay, we're graphing. Now, this is always an interesting question because it goes back. It's a nice review. So if we're going to graph this, we have to remember how to graph inequalities, and the type of line we draw, which is dashed or solid, comes into play, and we're shading. So remember, if it's an inequality, we have to deal with a dashed or solid line, and then we're going to have to shade. So, you may want to write this down just as a reminder to get you guys going. All right, x is being raised to the first power, y is being raised to the first power, so this is linear. So what we have to try to do is we have to try to get y by itself. So let's just take our time. If we get y by itself, I'm going to move the x over first. That gets me minus 3, or negative 3y, is greater than a negative 4x. It's a positive 9. All right, I got to get y by itself. So now here's the key step here. I'm going to divide by a negative 3. So just take your time. Divide by a negative 3. Divide by a negative 3. All right, a negative divided by a negative is a positive. 3 divided by 3. That's where y now is by itself. When you divide or multiply an inequality by a negative, you have to switch the inequality sign. This switches. You've got to remember that, guys. Multiplying or dividing by a negative, switch the inequality. I can't divide these two numbers, but a negative divided by a negative is a positive, so I'm going to just leave it as 4/3 x. A positive 9 divided by a negative 3 is a negative 3. All right, so, well, what do we know? Remember, we're trying to get it into this form, even though it's not an equal to sign, because that's how we're going to graph it. Y equals mx plus b. So the m is going to be 4/3. That's the number in front of x. Remember, your y is in the top and your x is in the bottom, so that's not a problem. And then your b is your y-intercept, which is a negative 3. Okay, here we go. Let's begin to graph this. So, on the y-axis, which is already labeled for you, I'm going to go down to a negative 3, and that's the first point on my graph. And then, using my slope, I'm going to go plus 3 in the x, followed by plus 4 in the y. Plus 3 in the x, 1, 2, 3, 4, plus 4 in the y. Do it one more time, 1, 2, 3 in the x, 1, 2, 3, 4 in the y. If you want to do it one more time, 1, 2, 3 in the x, 1, 2, 3, 4 in the y. You can see how all these points line up. I'm ready to draw my line. So it's greater than. Oops. It's greater than. If it's greater than, what type of line? Dashed or solid? It should be dashed because we're not including the points in the solution set because it's strictly greater than. So I'm going to line up these points with my ruler, and I'm going to draw a dashed line throughout. Now remember, we said in class, well, Mr. Worth, what if we forget to draw a dashed line and we draw a solid line? You can easily correct that by putting slashes through the line. Okay, so if you went with a solid line, just as an example, you can make it dashed by doing that. You don't have to redo the entire graph again. All right, put arrows on the end, okay? And then the last part of this would be to shade and to label. So let's go with the shading part. So we're going to go shade down here. And when we shade, we want to pick a point that's definitely on one side of the equal sign. that's a great point to pick, which is 0, 0. If it's definitely not on one side of the equal sign, definitely on one side of the line, so it's definitely on this side. If this 0, 0 makes it true, I'm going to shade the half it came from. If it doesn't make it true, I shade the other half. It's that simple. So what's I go back to the original equation. 4x minus 3y has to be greater than 9. I plug in 0, 0. 4 times 0 is 0. Minus 3 times 0 is 0 is greater than 9. Is 0 greater than 9? This is false. 0 is not greater than 9. So I need to shade the other side of the line. So I come down to my line and I shade this half. You don't have to color it in. This is perfectly fine in terms of shading it. Okay? Any questions on that? That's my solution set. Now I go ahead and label it. Remember to label. So I go to the side of the solution set, the side of the line, which is down below, and I label 4x minus 3y is greater than 9. All right? And then the last part of this question says, determine if the point 1, negative 3 is in the solution set, justify your answer. Let's go find out where 1, negative 3 is. 1, 1, 2, 3. 1, negative 3. So you can say 1, negative 3. Is it in my solution set? Well, it's definitely in the solution set because it's in that shaded area. It's right here. So it's in the shaded area. So 1, negative 3 is in the solution set, as you can see by the graph. The point is located in the shaded area. Right? Or you can actually take the point and plug it in, and if it makes sense, x is 1, so 4 times 1 minus 3 times negative 3 has to be greater than 9. So 4 times 1 is 4. Negative 3 and a negative 3, that's a positive 9, has to be greater than 9. 13 is greater than 9. Yep, it's true, so it should be in the solution set. Okay, so there's a couple different ways you can do that. Okay, last question in our packet. All right, we have another probability question that deals with arrangements, so let's take a look. We have a password consists of 3 digits, so 3 digits, 0 through 9, followed by 3 letters in the alphabet having 26 letters. All right, so now they're going to give you some restrictions. If repetition of the digits is allowed, so we can repeat the digits, but the letters are not allowed to repeat, so there's no repeat in the letters, determine the number of different passwords that can be made. All right, so we can repeat the numbers. So we have 3 numbers and we have 3 letters. Excuse me. Sorry. So 3 numbers. There are my 3 numbers, and then 3 letters. There are my 3 letters. All right? The numbers can repeat, so I have numbers from 0 through 9. Please be careful when you look at 0 through 9. You can count them on your fingers if you want to. There's actually 10 possible digits between 0 through 9. So I have 10 possible digits to put there. I can repeat, so I can put 10 digits there, and I can repeat, and I can put 10 digits there. Following that, now I'm going to choose a letter. Well, the first letter I choose, I have 26 different letters to choose from. But once I use the letter, I'm not allowed to repeat it. That only leaves me with 25 letters. And after I use that letter, I'm only left with 24 letters. So if I want to find out the total number of different passwords that I can form, I'm going to take my calculator out. 10 times 10 times 10 times 26 times 25 times 24. And you can see that's going to be quite a lot. 1, 5, 6, then 1, 2, 3, 4, 5 zeros. So 15,600,000 different passwords. All right, and the part B to this question is, it says if repetition is not allowed with the digits or the letters. So here we go, same question, same 6-digit password, but now I use a number. I can't repeat it, which means I only have 9 digits left. Once I use those 2 digits, I can't repeat it. leaving me with only 8. And then the numbers are going to be the same, 26, can't use it again, 25, can't use it again, 24. And we can see how that's going to affect all of this. It's going to be 10 times 9 times 8 times 26 times 25 times 24. And we're going to get 1, 1, 2, 3, 2, 1, 2, 3. And that gives us 11,232,000. So, you know, it's more than 4 million passwords that we reduced our numbers by just not allowing the digits to repeat. Okay? And that's it.